Well, ladies and gentlemen, welcome back here in room number 8. Our next presentation is API automation made easy for clients and automated tests. So please welcome Tobias Fenster and Simon Fischer.
Session. We're really happy to see such a crowd. We weren't 100% convinced, and we're talking about a similar topic at another conference where basically the audience was maybe 10% of this. So I hope we found a tech topic that's interesting for all of you. Of course, we're going to talk about API automation, how you can generate clients automatically, but also how you can mock your backends so that you can easily do development, automated testing, etc. To first introduce myself, my name is Tobias Fenster. I'm a managing director at 4PS by Hilti, a company in Germany. We create an ISV, a BC ISV solution for the construction industry. So on the off chance that you're working for a construction company, we also would be very happy to talk. On the probably slightly bigger chance that you're a technical person that looks for a new challenge, we're also very open. I'm also chief engineer at Hilti because 4PS is part of the Hilti group. And on the community side, I'm a regional director and an MVP for Azure and for Business Central, as well as a Docker captain. And if you find interesting what you're seeing here, please go to my blog, tobiasfenster.io. There you can find links to the social networks, indeed my blog, my podcast, etc. With that, I'm going to hand it over to Simon, who I'm very happy to have me join today on stage. So please, Simon, take it away.
Thank you, Tobias. Yeah, my name is Simon Fischer. I'm a software developer at 4PS in Germany, working together with Tobias. I initially started with .NET development quite a while ago already, back when it wasn't called AL, but CAL. And that I extended my focus soon after that to CAL. And I love sharing what I'm working on, at least if it's worth sharing. That's one of the reasons I'm here today. I worked with the community and Microsoft before on different topics for Business Central, for Azure, for PowerShell. And I think you can't overestimate how excited I am and also a little bit nervous to be on the stage here today. If you want to reach out afterwards, feel free to contact me via the socials or in the hallway during the walking dinner or whenever you see me. All right, with that being said, today I will start with showing how to automate the generation of REST API clients, what it is, why we need it, and of course a demo. After that, Tobias will show you how to mock APIs during automated testing, and hopefully we will have some time for Q&A afterwards. So let's dive right in. What is the problem? I don't know about you, but in my day-to-day developer life, I need to integrate more and more external systems. Often these are REST APIs, and working with REST APIs in AL is still a bit annoying, at least in my opinion. It got better with the REST client module, thanks to AJ and Waldo, but fully implementing an API still means lots of repetitive work and code. I don't know what's your approach when you start, when you get a JSON response from an API and you want to handle that in code. By the way, you have all these little lights. Who of you is working with REST APIs in your day-to-day developer life? Okay, I see quite some lights here. So, right audience, that's good. So you probably also created some custom data type conversion to handle the JSON you got from the API, or add some fancy messages to debug what your code is doing. And you probably also manually crafted the message bodies you send to an API, or the HTTP headers, authenticating stuff. That doesn't feel very modern currently in AL, and it's very cumbersome. So you probably know the pain of doing the same or similar things all over and over again whenever you need to integrate a new API in your system. And in other languages, they already have tooling to help with this, to not do it all manually. And so we are not the first to struggle with this in AL, of course not. Other languages are a bit farther with that. And you probably know a company called Swagger. Quite a while ago, they created a specification to define REST APIs. So all the entities, the operations, and relations in it. This became so popular that it was transferred to the OpenAPI Foundation. It became the OpenAPI specification, not OpenAI. And having this specification made automation possible. The specification has been adopted by a large number of companies. Microsoft is using it, Google, IBM, PayPal, and also a lot of smaller companies because of the tooling that is available. And part of this tooling is, or one of these tools is called Kyoto. What is Kyoto used for? You basically feed it an specification and it will generate the client for you. Kyoto supports .NET languages, Dart, Go, Java, TypeScript, and yeah, I know this is BC Tech Days, not .NET Tech Days or so. So now there's initial support for AL in Kyoto, so I added that a little while ago, and that's what I'm going to show you today. With that, I will come to my first demo. And just so you know, I will switch a bit back and forth through demo and slides to give you a better overview. And we will start with generating the first client. And first show you this. This is the demo specification that we are going to work with today. Swagger provided this pet store specification. It contains some entities like pet, store, and user, and some operations you would expect like put, post, get, typical, just very typical API. Everything that you see here is basically just the UI or for the specification file here. It's this JSON. And in this JSON, all the entities or the operations and possible paths are defined. So when you worked with an API before, you probably know these kinds of files. So with Kyoto, let me just launch it here real quick. What are we doing? We call to generate a new project with an OpenAPI specification, the one that I just showed you. Say which language we want to use and then in which directory we want to put it and the name. So basically the important part is just the file and the language in our case. It's already done. It's generated here based on timestamp you see was just generated. Let me quickly copy the symbol files so that when I open it in VS Code, I have no compile errors right away. But before I dive into the code, let me just show you one more slide. What did we just generate here? You will see an API client that basically provides some basic functionality and high-level entity access to all the entities you saw. Request client classes and request builder classes to talk with the API or execute the functions, and the model classes for each entity like pet or user that are wrappers for easier access with the data. What you will also see in a bit is that this extension has a dependency. In .NET, Microsoft has a package called Microsoft Kyoto Bundle that provides some library functionality for request handling, authorization handling. So I'm doing something similar with an extension called Kyoto Abstractions that contains similar helper functions and interfaces. So I will walk through this now. Let me first show you the result. I added a small test page, so everything you see here above is generated, and this one here was just copied by me. Let me just execute this or publish this extension so that you can have a look, that we can have a look how it works. So test page is very simple. We have a we just provide an ID, and we can call it get here. So when we call it get, it will query the API, and we have a response. There's a named test. We have status is available. The response was success. We could try, I don't know, any other ID and see, I don't know if it's also available. No, this pet does not exist, but I don't know. Whatever we use, we can just, okay, also doesn't exist. But we basically can verify it via the test here. Let's have a look, 999. Execute, and we will see it's test and available. That's basically the same we just got, but we didn't have to write a thing to make it happen. So, how did we do it? Behind this action, basically, let's ignore the variable resetting. Basically, the interesting part are these two lines. So we have an API client, and we want to call something on the entity pet. There's an indexer function which receives as a parameter the ID that we want to look up, and then we call the operation. In this case, it's a get. It could also be a delete or I think a post. So, but let's keep it at get. If it was successful, we can check the success response on the client. We just access from the return value pet, from the return pet, we just access the property name. So we can access any property. We have categories, that is ID, name, photo URLs is a list of text. So things that you would also, so that you can easily access everything. But yeah, the actually interesting part is then in the API client, right? So let's have a look. The API client, let's ignore the warning for a bit. We all know AL likes its variables sorted by type, and Kyoto likes it sorted alphanumerically, so that's just Kyoto style of ordering variables. We have some configuration methods in here. And besides the configuration, we have methods for each entity, pet, store, and user. Each entity method returns a request builder class basically. So and for each level of this, we just pass down the configuration of the current client that we're working in. So when we look at the pet request builder in our example, because that's what we worked with, we have all the operations that you also see in the specification. If we go back, we can see we have put, post, get. Under get, we have find by status, find by text, this index functions here, and an upload image. That's the same that we see here. We have find by status, find by text, post, put. And for the index functions, or the index operations, we have this method called item IDX. So it's a generic function. Whenever you have access something by an index, this will be generated, and we will pass down the information there as well. And on this one, we will have again the operations delete, get, post, but for the specific item of the entity. All these requests are built similarly. We pass down a config object basically to a generic request handler code unit and specify the HTTP method we want to use, and then actually handle the request. So for delete, we don't have a response type, but for example, for get and post, there are two more lines. If it was successful, we will pass down the response into the actual entity object. So each operation function is very small and generic. The part that's interesting is then the technical part is handled in the request handler. So let's have a quick look at the Kyoto abstractions. Sorry. That's the library helper app that I mentioned earlier. So in here, we have this request handler code unit. You can set configuration in here, set a body if we want to post messages, and in the end we have this handy request function, and it's also very simple build. We craft the request message with a REST client module code units, set whatever we need, write the body, and then send the message. And the little magic is in here because the config packages contains a reference to our API client. Here you see it returns an interface of Kyoto API client, and we set the response on this object. And this is done here. So as you can see, we pass down the reference to this code unit. So you set all the configuration on this code unit and pass down the actual object. So in here, we then have the option to read out the response that was set in the client, in the request handler function. So this wouldn't have been possible in earlier versions, or like this was introduced, I think, in the last major version. So this approach is only possible very recently. Yeah, that's basically the AL part now. But I guess you are also interested in how this actually works, and if you don't like the design, how you can modify this design, right? So let's have a look at the implementation. Or very quick, let's go back to the slides. That was now client in that. Oh, I forgot something, sorry. Let's go back here let's have one look at you saw the request builder classes. Let's look at one of the model classes. All of the entities like pet, user, store, and some others have corresponding code units so that you can easily access all the properties of it. There's a set body function with a debug switch so that you can test the reading and writing of all properties. But you don't need that always. But besides that, you have getter and setter functions for each property. So now the pet is a small entity with not too many properties. But if you have entities with like 200 properties, it gets a bit larger. And this way, for each property, you can just pass down an object of it with a value, and it will be set. Also, each model code unit has so-called toJSON functions or serializer functions. The toJSON without parameters will just return the currently read JSON body, basically, which we got from the API. And if you need to manually craft a new object, there's also always a function which receives all the properties as parameters so that you can manually build the object yourself, but without manually crafting the JSON yourself. This JSON helper is also part of this abstractions package, so that we don't have too many redundant code in each extension. And yeah, I guess that covers the AL part. How does this work in Kyoto? So Kyoto takes the specification file. It then walks down all the operations, the resources, the relations between them, and it creates a generic code model or document object model that is the same for each target language. So this model contains classes, methods, properties, everything that is the same for it builds the specification in code, basically. After that, some language-specific refinement happens. I will show you that part later on. And then this generic model is translated to the target language, in our case AL, but you could also translate it to C#, Java, TypeScript, or whatever you like when it is supported. So let's have a look at the Kyoto changes. Let's start at the refiner. The refiner, the language-specific refiner, you see there are refiners for C#, for Dart, for Go. For example, in AL, we don't have async await, and Kyoto by default adds cancellation tokens so that you can cancel long-running operations. But AL doesn't support cancellation tokens, so we can just remove these from the generic model. So we remove parameters here, cancellation tokens, and also the request configuration in this case, because we take another route in AL. But it basically, with this crawl tree, we just walk down all the elements from the top of the specification to the last operation and check if any element is there containing this, what we want to modify. There are also some functions, for example, move properties to methods. In C#, you probably know you can just add a get and set to create a new property on a variable. In AL, we don't have these property identifiers or access modifiers, so we just add this getter and setter functions. So everything that happens in here is so that we have a working AL model later on. And with this generated code, we then, for each element, the specific variety is called later on. Let's look at the one for code units. That's called a code class declaration writer. And we come in here with a class declaration element. And basically, we first check if we have any namespaces or any usings. We write that first. And when this is done, we will write the actual code unit identifier, get an object ID, get the name, and start basically the object with properties like access internal or other properties that we might define as defaults, and then if there are any global variables. So we have basically now the header of the code unit, and after that we can go to the methods, because code unit consists of methods and variables, and we already handled the variables part. So let's have a look at the method writer. This is a bit more there are more different cases here. First, we write basically the signature of the method, if it has an access identifier like internal, and then the method name, the parameters, and the return type. After that, we just start with the begin, handle the actual code in the method, and after the end. Let's look at one of these methods. We have different cases here. For example, a serializer or a request executor. The serializer, in our case, are these two JSON methods. So we want to serialize the values that we have on the object back to JSON. And we have two different kinds of methods, one without parameters and one with parameters. So the one without is easy. We just return the current global variable that is defined in the as global. And if we have a JSON method with parameters, we create all these all the lines of code that you basically saw in here. So add to object if not empty, and the target one. So if it's a collection type variable, we iterate it, and if not, we just add it. There's a different case for enums. If we want return it, we might return it as integer, but yeah, that's basically how we write everything. You see there are quite some messages or some methods in here that we need to handle. And right now it's not perfect yet because I needed to do a little workaround. You will see some helper functions in here, like this is local variable, because my goal was to not modify Kyoto standard code except for the parts where the enum, like add language support for AL, was necessary. But I only added new objects and didn't modify existing ones to make it easier later on to merge it back to the Microsoft repo. So we have, I have introduced so-called custom properties. And the custom properties is a small workaround where each Kyoto element or code element has a generic documentation property. And basically, I just append to the documentation property, I just append some key value pairs with these properties and later on read them out. So here, for example, it's written to the description template. It will be stripped away before actual documentation is written, but that's a workaround right now to avoid modifying the standard Kyoto code. So if you stumble upon these custom properties, just know it's currently a workaround. I'm not sure if it will be in the final version. I also explained some of these things to make it easier for you if you want to work with me on this fork. Added a README to make it easier to get an idea of this repo, because Kyoto has quite a massive code base, and yeah, this very generic approach took a while to really wrap my head around. Yeah, I think that's for Kyoto right now. Current state of this change. I initially created a pull request in the Kyoto repo, but I was unaware that there is a community approach that they used before to add new language support. So right now I'm in contact with one of the maintainers so that we bring the code in the community repo first, and then after it's basically tested there, we will merge it back into the main repo. This companion app, the Kyoto Abstractions that I showed you earlier, is currently in my personal GitHub, of course public, but my goal would be to make it part of the system app or a Microsoft app so that it can be shipped by default with Business Central, so similar to the, I don't know, Azure Blob Storage module. And right now, please be aware there might still be bugs. We still need to test it. It's an early draft, but it would be great if some of you clone this repo, try it out, test it against your own APIs or the ones that you are working with, and give feedback. And let's try to make it production-ready code. If you want, check out the repo. Of course, I will afterwards also publish a blog post containing, I don't know, 20 different links to answer all questions, which resources you might need. So don't worry, there will be a summary post afterwards. And with that, I will give to Tobias.
Thanks a lot, Simon. Yeah, give a round of applause. Simon did that work. I hope this gave you an idea, and I can only echo what Simon said. Please help us out here. Take a look at it, improve it, give us feedback what you want to do differently, mostly Simon feedback. And then I hope we can create something that will help all of you with the work on API clients. With that, I want to move into the second topic, and that is kind of on a related problem, because the basic starting point is the same. We need to integrate more and more systems via APIs. That's what Simon explained, and I think by show of your lights, you showed that you also have that problem. But that's not the end of it. We, on the one hand side, have the topic that we need to integrate into BC, when we also have the topic that BC needs to integrate into other third-party systems. So it's not only about the APIs that we have in Business Central, but it's also APIs of third parties. Simon showed you how you can generate a client for that, and I want to show you how you can tackle a different problem, which is that we, during development and test development, we often face some challenges. I guess it's kind of similar for you, where it might not be that easy to have the systems available. For example, if you're integrating with a third party, that third party might actually be kind of a competitor, so you might not even have access to it. or they limit it to a very highly priced model, or they are just technology-wise not aware that there might be something like a dev environment and they are not stable enough, so you might get flaky results by talking to their test or dev environment or something like this. Then we have the topic of data, so what you specifically want to do with a third party, or even what you want to do in BC. You oftentimes, for those API integrations and test automation, you need a specific set of data. And that, of course, can also be a challenge to generate that data, to have it in place, and make sure it's there when you do your development or run your automated tests. And then the last part of it could be scaling, depending on what exactly you are doing. Maybe it is a challenge that 3 different people are doing development, or 3 different pipelines are accessing the same backend system. You might get into each other's way. That might, again, be Business Central or a third-party solution where you have that issue. And the question, of course, is how do we solve that? An approach to that can be mocking, where the idea is that instead of having the real Business Central or a real third-party system, you have a mock instead. And what that means is that it accepts the same requests as long as they are relevant for you as the real system, and they respond with the same responses that the real system has. So that means that instead of talking to the real system, you talk to a mock that stands in between, behaves, acts like the system that you want to integrate with, and so you strip away the dependency on the actual system. You only depend on your mock, which you have very much under control. So that's basically the main idea I want to talk to you today about. How can we mock Business Central? So if you create additional clients like an additional front end, an app, a portal, or a third-party system, or if you want to mock a third-party system that you want to integrate with, how can we do that easily so that during development and automated testing you don't have the dependency on those systems, but you have everything under your control. What I want to use here and introduce to you is WireMock. You can see the description that they provide on their homepage, an open source tool for API mocking. And the last part I think is very interesting. It's about isolating yourself from flaky third parties. That's a less friendly way of saying maybe there's someone else who isn't in full control of their environment and of their technology. You don't want to depend on those kind of offerings. Instead, you want to have it under your control. It does allow you to mock those APIs through JSON files and through code, and we will see both approaches today. We can not only do that by hand, we can also record those API calls. So we basically make the API calls, get a recording, and use that to create our mocks. And we can also implement stateful behavior. I'll show you in a second what that means. Of course, we're at a developer conference, so the first thing we're going to do is a hello world. And let's dive into that one. And what we want to do in this hello world is we want to create that mapping, we want to load the mapping, and we want to make the request to the system so that you can actually see the hello world. How does that work? We will create a hello world.json file, and I hope this is big enough for you to read also in the upper area. Looks like it, okay. So what you see here in this JSON file, the first part is the request, where we have the get. So we're basically saying when a request comes in, it's a GET request, and it has the URL of some/thing. Then we want to react. How do we want to react? We want to create a response with a status code of 200. We want to send a body, hello world from BC Tech Days, and we want to send a header with it. If we now ask WireMock whether it knows about that, there is an admin API that you can see here. So __admin gives access to WireMock itself, so to speak. And if we ask it about the mappings, then we get an empty response because we have just now created that JSON file. So what we need to do is we need to reload those mappings. We've done that. If we now ask it again about the mappings, then you can see here, this is the list of mappings. So you can also query WireMock and ask it, which mappings do you know? If you get weird responses or something you don't understand, that gives you an insight. With that, we have it in place. So let's show the actual hello world. We're just gonna call the WireMock server on some/thing, and it responds with hello world from BC Tech Days. So this is basically the very minimum way how you can use WireMock. You start an instance, you put the JSON file somewhere, you might have to reload the mappings, and then you get the responses that you defined according to the requests that you defined. So what have we seen? We created the mapping, we loaded the mapping, and we made the request and saw the response. So I would say hello world is accomplished. what is the real scenario I want to tackle? The first one I want to tackle is mocking Business Central. So basically, you can assume that you have a client application or some other server system that makes an API call towards Business Central, but instead of calling it directly, we want to call WireMock. So we use it to do the recording in this setup, and then we can basically strip away Business Central completely because WireMock now behaves exactly the same as Business Central would behave. So I no longer have that dependency on on Business Central, but I only need my WireMock server. And as an example, we're going to get companies because we always need companies when talking to the REST API. And then we're going to do reading, creating, updating, and deleting of customers. So the CRUD actions on customers. So what we need to do is we need to mock the responses for get companies, for get customers based on the company, for getting a specific customer based on the company. And all of that we're going to do in standard WireMock in Java. So WireMock originally comes from a Java backend. I'll also show you the .NET implication in the later part. But first, for the first one, we're going to use the Java implementation and record and optimize those JSON files. As a client, and that's actually the less interesting part because I basically care about the mocking and less the client. So I only created a tiny C# application for development and testing that is done in dev containers. So we have one container for the client application, one container for WireMock. So we always have access to that one. And if we have time in the end, I will also show you how that setup works. Kind of the advanced topic that I also want to show you here is stateful behavior. And we need that because we want to create a customer, read, update, delete the customer. So basically our scenario is that we want to create a new customer and only then can the customer be retrieved. Before it's created, we expect to get an error message when we call for it. We also need different responses before and after the update has happened because we changed it, so the response should be different. And then after it was deleted, we again expect to get an error when querying for the customer. So this basically is the setup of the stateful behavior. Depending on previous calls that were made to the mock needs to react differently. We can't just define everything statically, but we need to have some kind of a dependency. And that is done via scenarios. We have a name, we have a required scenario state. That means where does the scenario need to be so that a specific call is happening. And then we have a new scenario state if we want to move ahead in the state. That also means that we now need to mock additional endpoints. So we now, when we query for the customer, need to have different responses, where it has been just created, whether it has been updated, whether it has been deleted. We also need to implement the post and the patch for creating and updating the customer, and then in the end, the delete call to make sure we can also remove it. How does this work? Let's jump back into our demo. And as a first step, I want to show you how we can record that. You remember the hello world JSON we just created, but that would be a lot of work to create all those requests and responses. So instead, we can tell WireMock to start recording. Then we make the calls that we want to mock. We stop the recording, and then as a result, we get the files that contain those requests. So the first thing we need to do is we need to let WireMock know that we want to start recording. There again, you can see a call to the admin API to /recording start. We let it know in line 15 what the target base URL is. So that's basically the instance of Business Central I'm targeting. We let it know that we want to extract the body. What that means you will see in a second. And also we want to capture one specific header. I could also capture all headers, but probably not necessary. But if you worked with the Business Central APIs before, you know that there is this if match etag header that is important to make sure you can only patch something or make changes to something when you have the latest state. So we also want to simulate that in our mock to make sure in our client we also respect it properly. If we call that, we just get a 200, which means recording has started. So now we can go in and make the calls that we want to make. In this example, I have set up basic authentication. Note that in line 7, I'm now not talking to the Business Central instance, but to WireMock, because WireMock is acting now as a proxy between me and the Business Central server so that it can record the settings. First one that we're doing is a get for the companies. And if we make that call, it now takes a bit, almost 2 seconds, because we have targeted Business Central, so there is a bit of a response time. Then we store the first company ID in a variable and then get all the customers. Now we get a list of all the customers. We remember the first customer ID and get a response for that one as well. Now we want to create a new customer, so this is basically the post request. We give it a display name of Ulm Falcons, which is the baseball team of my son, so I want to show this to him that I actually used it here. And then we get the response. You can see here the display name is Ulm Falcons as expected. We need to, again, remember the ID of that created customer and try to retrieve it. So if we get that one, that works. And now I need to do a little trick by copying the E tag because I couldn't figure out how to properly read that from the response. But with that, we should be able to call the update. Now the display name is TSG Söflingen, which is the basketball team of my other son, so everyone in the family hopefully will be happy. And we can get the created customer, get the modified customer again. So now the response in the display name should again be different because now we basically made a change. Business Central, of course, is aware of that, but when we mock this, we need to keep this in mind. Last thing now is to delete the customer, which is just a delete call. We get a 204 response. And if we try to get the deleted customer, we get a 404 because the customer is no longer in place. So this is basically the scenario that we want to mock. We get a customer, we create a customer, we update it, we delete it, and we have the different GET requests in between to make sure we have everything in place. Now I stop the recording. So from now on, WireMock is no longer proxying towards Business Central, but instead when I now talk to WireMock, it's only based on those mappings that we have generated. So if I now would do a call towards a, I don't know, sales order or something like this, it would no longer forward, it wouldn't have a mapping about the sales order, so it no longer would be able to respond. What have we seen? We started the recording, we made the calls, and we stopped the recording. And what that means is that we now have a bunch of files. So you can now see here in the folder that we have, for example, the body of the call to get companies. And here we have the mappings that also are generated. But they have those cryptic names based on the URLs and the IDs that are in there. So we want to do something about that. If you just use them as it is, if this works already out of the box, if you don't have state, etc., then it probably is fine if you just keep them. If you keep working on those APIs, then it makes sense to rename them to something that's a bit more meaningful. So we need to also make some improvements. I want to show you how we can make things a bit more dynamic, which is why I have renamed the files, so it's a bit easier to navigate. And I would encourage you, if you work with WireMock, to do the same, to give them a bit more meaningful names than just the generated IDs. So if we move forward, this would now be the example of the call to get companies as we've seen before. It's just the name is now companies to make it a bit more easy to read. We have something very similar to the Hello World. In this case, it's a GET request to /companies. And here we have the response, in this case, 200. The content type is set and the value of the company is also included. Now, this is basically a very small file. I can still overlook it. So here we could have the body still embedded in the mapping file. What you also see is that we have a fixed ID here. And of course, in Business Central, that makes sense because we're going to reuse that ID for later calls, and the ID needs to be the correct one. But you also might have different scenarios where you want to randomize such an ID. Or if you work, I don't know, with items or something else where the IDs are not fixed, you could use something that you can see here, where you just generate a random value. So if we now reload the mappings, and make the call, then you can see on the right here in line 10, it's now an ID that starts with 80. If we make the same call again, it's an ID that starts with 81. So you can see the randomization works. Of course, in Business Central, that's not too helpful, so let's switch it back to the fixed value. But just to give you an idea, you can randomize stuff in here. Another example would be a date field, like the system modified add that we can see here. That one would now be fixed to a date somewhere in February. But maybe as you progress, you keep using your demo data. You want to make sure that those date fields don't get too old. So we can also do something like this, where we say this is now -7 days. So this is basically now created dynamically instead of using the fixed value that we've seen in before. So if we reload the mappings again and make the call, now you can see in line 18 that it now says last modified date was on the 5th of June, which is a week ago. So basically this is a bit of the dynamicity that I can bring in here easily. Another part of the request is when we get customers. For example, we have the get request here. This one points at a specific customer. The response you can see here, where we have a lot of headers. We have the status, and we have specifically here a body file name. That is what I mentioned in the recording, that I want to extract the bodies into a separate file, which has happened here. So now I don't have the mapping and the body mixed in one file, but I have two files that I can handle separately. And this is just what the body file would look like. I just have the JSON payload, and I can easily handle that and manage it. Another example is the request to create something new. So here in line 6, you can see that I'm reacting on a post request, and I'm now matching the full body in line 9. So I'm basically saying the body has to be exactly the display name, the type, etc. And then I want to react on it. The reaction now has a different status code of 201, and I'm again extracting the body into a separate file to make it a bit easier to manage and handle. The next example, or to show you how that works, would be the patch call to update a customer. So very similar to the thing that we've seen before. We have the if match header here. So this one makes sure that the eTag if match logic in Business Central also is mocked in our wire mock, so that whatever client you generate, whatever client you develop, also is sure to handle that properly. Otherwise, you might run into issues when you talk to the real system. The response, very similar, extracted to a body and a status of 200. Last one I want to show you is the delete call. That one is again a bit easier because we have the method and the URL, of course, but the response now doesn't have a body at all, but instead we just set the status 204 in line, what's this, 9. So basically the delete call doesn't return anything, just the status, and that's it. So that makes the mocking a bit easier. So that's what I wanted to show you, how you can structure those files. Make sure you have proper naming in place. My suggestion would be to remove the bodies into separate files so it's a bit easier to handle. And you've seen how we can use those pre-recorded files, but still have a bit of dynamic behavior by using the randomizers or by using the date changes that you have seen. We also have the state topic, and unfortunately that doesn't exactly look like I wanted it to, but let me show you. This is basically the state graph that we want to implement. So on the left we have the fact that the customer is not yet created. This one should respond to a call to the customer with a 404. Once we created it, it goes into the state created. Now if we try to get it, the response should be the created customer. Then we have two options when it is created. We can modify it, and then the response is the modified customer, or we can delete it. We can also delete it after it has been modified, and in the deleted state, it now must return the error message again because the customer is no longer there. How do we do that? We have two or three, depending on the file, additional elements in here, and you can see in the create that we are starting what is called a scenario. So the scenario basically is a collection of those states. We call it CRUD customer, and after the create, we can see that the new scenario state after that call has happened is now CRUD customer created. So we basically have our scenario and we move it into the first state. Then if we try to get the created customer, you can see here that it only reacts via the required scenario state if we are in the created state. So only if the create call has happened, we move into that state, and then this one matches, so the response is that we've seen. Same for the update call. In the update, we expect to be in the created state because we can't update it if it's not there. And once this call has happened, we move into the updated state. And I actually also wanted to show you the delete, but I guess you can imagine the delete can only happen based on the modify and the updated, and then it would move into the deleted state. If we now take a look at the scenarios, you can see we have the created state, we have the deleted state, we have the updated state, and it also shows all the mappings so that you understand what contributes to your scenario, so you can keep an overview if something acts weirdly or doesn't work as you expected. So what we can now do, that we have all of this in place, is that we still talk to WireMock, but because we're no longer recording, we're no longer proxying, this is actually using the JSON mocks that we have provided. So if we do a get, we still get the expected response. If we do a get for the customers, we get the right response because we have mocked that. If we query for a specific customer, we get the right response. We can create a new customer with the name you see in line 42, and we get the right response in line 22. We try to get this customer. Again, this is sending us the right response. Then we try to update it. And I forgot to change the e-tag. So now you can basically also see what happens if we don't have a match. It lets us know that it actually works. So we see the closest stop. The scenario is the right one, but we don't have the right e-tag. So let's try to, oh no, that's the wrong one. No. Doesn't want to let me copy the right thing. Let's try again. Call the modify, and now we have the modify. The name is changed to what you see in line 20. Then we can also get the modified customer because we have now moved the scenario one state ahead. It also is returning that one. We can do the delete. That one accepts just response with a 204. And if we now again query for it, we get the error 404. And just to remind you, this is now all talking to WireMock. It behaves exactly the same as Business Central would behave, but we don't need a Business Central system in the background. We only need our WireMock server with the configured JSON files. So what you've now seen is how we can implement that stateful behavior by setting those scenario state, required scenario name, required scenario state, and new scenario state by moving things ahead in our state graph. So what we now want to do, and that's actually the most boring part, I think, of the demo, is that we want to use the mock to show you that we have everything mocked and how we can use it in development and testing. And as I mentioned, for that I have created a small C# client. What that client does is that it just gets the companies, iterates over the companies, and shows the responses, and also gets all the customers per company and shows all of them. Then we go in and retrieve a single customer where we know the ID and show it. We create a new customer. Again, we make sure that we have the right body because otherwise WireMock would not react appropriately. And then we read it again. We have the update call where we change the display name and make sure that the change actually happens so we get the right response. And then we delete it and expect the delete to fail. In C#, that means that an exception would be thrown that we can handle. So if we just run that one, you can see that it's sending the requests, and from the speed that it has gone through all those scenarios, you see that this is now actually talking to WireMock and not to an actual BC backend. So this would be the client application, but we can not only use it for clients, but maybe more interestingly even, we can use it for automated testing. What would that look like in C#? I'm setting up a number of constants here, and then we would have, for example, in a call that retrieves a specific company, makes sure that there are actually companies, checks the first company, makes sure that is the right name and has the right ID, and also the modified date that we added the dynamics on is newer than 8 days ago. A similar one would be that we get a specific customer. So again, we use a client to get a customer. We make sure that it has the expected display name, has an email address in this scenario, and also has a valid modified date. I'm also trying to get a specific customer here. There I'm again checking the display name and the customer number. I have the create call where we set up a new customer and then retrieve that new customer. So we make sure that the post also works by checking the responses here again. And we have the update where we basically first create the customer, we update it, we make sure that we get the right value when we query for the update. And in the end, we again have the scenario where we delete a customer and make sure that the customer actually no longer exists. So this is just standard test code, and it would look exactly the same if you would query a BC system. So that's kind of the main point I want to make here. The test code doesn't change. You write your regular test code. The additional benefit is that you no longer rely on Business Central, on a Business Central instance to be available, but instead you just spin up your WireMock instance. So if we look into the tests and run them, once compilation has finished, that one should be quite fast. Yeah, it has been 418 milliseconds, so basically the whole scenario didn't even take half a second, which again is an additional benefit of doing things with a mock backend, because you're a lot faster. If now the backend changes or my client code changes, I as a developer can figure out very quickly that things are maybe broken, and in my pipelines this only adds a very small amount of time to make sure my integration still works. So this is what I wanted to show you for using the mock. Basically now we have the full life cycle. We have seen how we can create the mock for Business Central and how we can use it in development and test development. That basically concludes the first demo. So you've seen the recording, you've seen how we can record the steps that we wanted to do, how we can optimize them. You've seen a bit of the renaming, the dynamic values, and the header handling, the e-tag handling that's specific for Business Central. You've seen how we can handle stateful scenarios and also how we can use the backend for development and test development. Now that's basically the first demo, the case when we want to mock Business Central, but also we have the other way around. In this case, we're in Business Central and we have a third party that we want to talk to, similar to what Simon showed us as an example, when you have a REST API and you want to integrate it into Business Central. Again, we take the same approach. Instead of talking to the third-party application that we maybe don't have control over, where we don't have proper dev and test setup, instead we put WireMock in between. And when we have set it up, we don't need the backend system anymore. We only rely on stuff that we have on our full control. And I want to use also the exact same example that Simon has shown you, the pet store application, where we want to do create, read, update, and delete again. And I will also use a client that has been created through Simon's Kyoto edition. So this is basically the generated code in action again. What we need to mock is the get call. So we want to get a specific pet, and we want to also get random pets, as you see in a second. We want to create a pet, so we have to mock the post call. We want to modify it, which is the put call, and we want to delete it, which of course is the delete call. This time I'm using wiremock.net. The reason for that and not using standard wiremock is that my Java days are a bit past, so I'm more okay with using .net. And that's why I switched to wiremock.net, so we can use it for recording, and also then when we generate code, I'm a bit more familiar with that. But the basic concepts are the same. You have the mappings, you can do dynamics, you can do scenarios, etc. The client now is in Business Central, as we've seen in Simon's demo already, and I want to show you how we can use it during development and testing. So how does this look like? Let's go in here again. What we want to do is, again, as in the last example, I don't want to craft all of this by hand, but instead I want to do the recording, make the calls, stop the recording, and then I want to show you an additional tool called WireMock Inspector that we can use to generate the code. So this time we're in .NET, and you can see here that we set WireMock up. So this is just the standard configuration. We wanted to listen on port 9059, and we don't care about this message. We start the admin interface. This was the __ admin calls that you've seen before. If we want to have that, we need to enable it, and we have a logger that just writes some output. And then if we are in proxy mode, we have two additional settings, which is the proxy URL, and we want to make sure that the mappings are saved. So this is basically the setup, how we tell wiremock.net that it should start in code, that it should start in proxy mode. How do we do that? We have two arguments to our little application, proxy and then the URL. So you can see if we started like this, then we are proxying towards the pet store application that you've seen with Simon. What then happens next is that we have two different outputs. If it's not running in proxy mode, we say so, and if it's running in proxy mode, it tells us which URL it's proxying to, and then it basically waits until it is cancelled by someone, so I can just hit Control-C or kill the process or whatever, and then the application stops. Now if we run that one, you can see here below the parameters, so we do a .NET run proxy pet store Swagger IO, so we expect it to run in proxy mode, and you also can see the output down here. It says running in proxy mode and proxying requests. So basically now when we make the calls, as you can see here, talking to localhost 9095, where now WireMock is running, and do a call to the API for pet 999, as Simon has shown you, it will make the call to the real backend and return the response, still the same, 999 with a name of test and a status available. So this is basically what we expect, but now WireMock is again recording it. To take a look at it, I want to show you WireMock Inspector, which is a tool to interact with WireMock.net. You can find it at this URL and install it simply using a .NET tool install, and then connect it to the relevant instance, in our case, the localhost port 9095. And if I do the connection here, I can now see, yes, indeed, it has gotten a request, the pet 999 request. I can take a look at, for example, the path, which was API v3 pet 999, etc. No query parameters, no headers, no cookies. We can also take a look at the mappings, because we told it to save the mappings. Basically, we are in recording mode. It also has that one, which shows us, okay, what is the definition, the request, the response, etc. It has a tab for scenarios, which we will take a look at later. At the moment, we don't have any. And a nifty thing here is also that it shows all the settings. For example, we see here that it's running and that is having the safe mappings, and it has a proxy URL set. So this is very useful to make sure you started it with the right settings. And because the documentation is a bit lacking in some places, it's also a nice way to see which settings are actually available that you might be able and interested to use. And as I mentioned, we want to use this to generate the code. So I can take a look at this request and then, for example, say I'm interested in the method, I'm interested in the path, I'm not interested in the request headers or the cookies. The request body and the status code is relevant. The response headers I also don't care about, but the response body. So now I have basically the code that I can just use and put it in my C# application, which is what we want to do next. But we also want to make sure that we have a bit of dynamic behavior in this one. So what I want to show you is, again, how we can randomize the responses, similar to what you've seen in the JSON files. But I also want to show you how you can use parts of the request in the response, and how we can even add custom logic and custom code into that one. So let's put the right code into our little application that we have just created. So if we are not running in proxy mode, then we want to add a mapping. So this one will react on the get call to the 999 request, and it will respond with a status code of 200. I'm also adding in line 54 a specific header, so we can also immediately see that this is something that WireMock has generated. And then we have the actual body in line 65 to 62, 56 to 62, where you can see the pet that we have retrieved. So if we now go ahead and run this, why didn't this run? Let me see. By the way, this is an amazing extension called demo time that very often works perfectly. So this is now basically starting our server. Again, you can see it's running in non-proxy mode. So this is now basically only working on the calls that we have defined. And if we then make our GET request, you can see that it responds with the 999 as expected. So we're getting the mapping that we have just defined in our code. You can see here that the path currently is fixed, but maybe we want to make this a bit more flexible so that we, as Simon has shown you, can just change the IDs but still get a valid response. So what we can instead do is that we don't use the hard-coded path, but we instead use a wildcard matcher. so that whenever something calls in that is a match, and you can see here that we basically accept everything, then we will respond to it. But we have in our response also still hard-coded the ID and the name, which obviously doesn't make sense. If we make the request dynamic, then also the response should become dynamic. So here we can do an access to the request path and access the different segments. So the first segment would be API v3, the second would be PET, and the third, no, first is API, second is v3, third is PET, and the fourth one, which is addressed as 3, of course, is the ID. So this is the way how we can access parts of the request and use it in the response. So whatever we have requested now should also be part of the response. And to make that work, we also need to add this with transformer call to make sure that those transformations actually happen. So if we generate our application again and let it run and make the call to the backend and change the ID. So for example, now we are requesting 429. We get a response, and there you can see in line 9, indeed, the ID is 429, and the name is now PET429. Well, basically, now we are reacting in the response on the request to, again, make it a bit more dynamic. The next thing that is statically defined is the status. So we only have status available. Whatever we call, we will always get available, which is probably also not what you want. What I first thought, and that was a bit of a learning that I wanted to share with you, is that I could do something like this, where I create a function here, get random status, that just has the available status, available, pending, and sold, and then return a random one. And then we use this function and reference it here in the status, so we just have a get random status. Let's run this, and then show you what happens. Because if I now do the GET request, I get available. And if I do it again and again and again and again and again, I'm always getting available. And the reason for that is that WireMock goes through the code initially and only calls the get random status basically on initialization. So if I run the server again, I might not get available, but maybe sold or pending, but it will for all requests be the same, and that most likely isn't what we want to do. So instead of having a call here that is only executed once, we also can use one of those handlebar templates. Those are called the dynamic handlers in WireMock.net, where you can see that now we want to randomize based on a string list where we have those available values. And if we now go ahead and create it again and do our get call once again, you can see now pending, now available, now sold, available, pending, sold, etc. So this is basic. That was always the same order. No, now it's different. It's getting a bit worried, but yeah, it's actually really random, but for 3 it can have some patterns, of course. So this is the right way if you want to randomize something like this. Now we have 2 additional areas, the photo URLs and the tags, and those are also statically, in this case, mapped on empty arrays. And WireMock doesn't bring something that's suitable to have random results for that one. So what I want to show you is how you can bring in your custom code and then properly reference it instead of doing the thing that I did with the get random status, how to do this properly. For that, we first need to register a helper and give it a name. So you can see here the name of our new helper is a random string array. And then we have a piece of C# code that just gets random words with a minimum and a maximum length and then splits them so that we get an array of words, basically. The second example is our URL helper. So we also want to get URLs. That one is the random URL array helper. It also has a minimum and a maximum length. And it goes through the URLs and generates the URLs. You can see here how that works. I just have a list of domains, of image extensions, and I generate a random name, put them together, and that creates my random URL. You can see here I also didn't do a lot of work in creating the data set, but still this might be enough to just generate random URLs. What I now need to do is that I need to register them. So in startup, I say that I have a callback, and that callback registers those URL handler, that URL handler and that string array helper that we've seen before. How do we reference that now? We gave it a name, random URL array and random string array, so we can just put them in, and we had the minimum and the maximum length as parameters, so that is what you can also see here. So we have between 0 and 3 photo URLs, and we have between 0 and 5 tags that are added. Well, now if we run our application again and make our get call again, we should see random photo URLs and random tags. Oh, go back one step. And now you can see that's a different one. Calling it again a different one, calling it again a different one. So now we've basically randomized the responses again. That's what I wanted to show you for the dynamicity. So you've seen how we can use the request in the response. You have seen how we can do a bit of randomization, and you've also seen how you can bring in your own code if the randomization, the dynamic stuff that is in WireMock doesn't fit your needs, then you can also provide your own code. Again, we also need stateful behavior for the pet store that is very similar to what we've seen in Business Central with the customers. So it needs to be created. While it's not created, we want to have an error. When it's created, it can be modified, it can be deleted, and the responses need to be the right ones. So that's basically the same state graph as before. And how does it now look like when we go into code mode? Here you can see that we have the initial get, and I use the ID 1000 for our special pet that we want to create. And while it's not there, we will just respond with a 404 because the pet doesn't exist yet. Second step, of course, then is to create a new pet. To make it a bit easier, I have also created record classes here. So the pet has an ID, a name, photo URLs, tags, and a status, as you've seen before. And then we can use this to just define our pet. So whenever we get a new pet, we call it Fluffy, and then we will mark it as tagged because, of course, there's some AI that figures out that Fluffy is very, very cute. But how does the actual request look like? Now we accept a post. We again have a wildcard matcher on the pet URL, and all we care about in the body is that the name is Fluffy. So you can also see here in line 101 the JSON partial matcher. Compared to the full body that you've seen in the JSON example, this would be an example where you say, I don't care what anyone is sending. All I care about, there is an element name, and that has to be Fluffy. So you also don't have to react on the full body, but you can also react on parts. And if that is the case, then we will also move our scenario ahead. That is basically similar to what you've seen before. In this case, we have a pet CRUD scenario and will set the state to Fluffy created. So we're moving our state graph ahead, and we will respond with Fluffy. Now, if we want to get it afterwards, you can see the GET request to pet 1000. And this one only reacts if Fluffy has already been created, and it stays in the Fluffy has been created state. And it responds with Fluffy, of course, because that is what we just generated. Then we add the update. So in this case, we are changing Fluffy to sold because someone bought Fluffy. The method now is put. And as a matcher, we again only care about the ID and the status. So whenever someone sends something in with the ID 1000 and the status sold, then we change that. If someone would also send in the name, in this case, we would ignore it. So this really depends on your scenario and your case. Again, we are only reacting if Fluffy has already been created, and we move ahead the state to Fluffy was sold, and we return the sold Fluffy. Next step would then be to also respond to a GET after Fluffy has been sold. So again, you see this is only responding when Fluffy has sold and stays in that state, and it returns the sold Fluffy. Last one is that we want to delete Fluffy. Again, this is happening both in the created and in the sold state. So we're doing a bit of a for each here. We accept the delete call. We take it in the pet CRUD scenario if it's either created or sold, and then we set the state to deleted. And we only return the status code 200, which is how the pet store works, and the message of pet deleted. So basically, this is, again, moving our little pet through that state, through its state graph. If we now run this application again, And it has started. And then we can use all those calls. But what I first want to show you is that WireMock has that scenario inspector that I mentioned before. So if I now reload, because we now have defined scenarios in our code, it recognizes that there is a pet CRUD scenario, and it basically creates the state graph. So I can also see when I create something in code, it generates a graphical representation for me so that I can understand what happens, and I can see which transitions are supported and through which definitions, where they are triggered, etc. So this gives me a better idea after creating the code whether I have actually created the stateful scenario that I wanted to create. Now let's give it a try. First try to get a pet. Of course, we haven't created it yet, so it responds with a not found. Then create the pet, Fluffy, it responds as we expected. We try to get it again. Now it works because we have created it. Our state graph has moved ahead. We can update it. Again, the rest of the body basically doesn't matter. We only care about the ID and the status. And now the status has moved to sold. If we take a look into the WireMock inspector again, it has the nifty feature that it also shows us in which states it already has gone through and where we are now. So I can see it moved through created into sold, and I know which transitions have happened. To show you, I can also do the get. Now I see the get with the status sold. I can delete it. It responds properly. And if we now do the same get call, I had not found because we have, of course, deleted it. So again, we have now a WireMock instance in place that completely replaces that pet store, and I'm no longer relying on it. Instead, I can do that state graph. I can do the dynamic handling and everything without relying on pet store, so I can do my client development independently. So what have we seen? We have seen how the setup for recording works, how we can record the required steps and generate the code. We've seen some of the dynamics using the requests and the custom handlers, seen the partial body matcher, WireMock inspector is a nice tool, and how we can handle stateful scenarios in this setup. Now I also want to show you how we can use that from Business Central. And now we're going to basically use the Kyoto generated client that Simon has shown you. And I have extended the demo page a bit for this because we are changing the status to sold. I also wanted to show that. And I added some actions to create, update, and delete because Simon so far only had it in the get. So what did I do? That's kind of standard AL code. I just added a status enum. I added the pet create action, which does a post call. So as you can see, this is now using the client pet post in line 107. This is the nice handling that we get through generating the client via Kyoto. And then we make sure that the response is successful, set the status, and show the output. Modification works like this. Again, we're using in line 131 the client that has been generated. We use the indexer to access the right ID and get it. So this one should basically show give us the right pet. And then in line 135, we have the put call. So we do now the modification after we change the status. The delete action, also very simple. We get the right pet using the indexer and just call delete. And then show the response, but basically the API interaction thanks to Kyoto is just the one line in 157. And I've promoted all the actions so that they are visible. So now let's deploy this. Yay. What happened here? Let me try to reload. Here we go. Try to build. Okay. Try to publish. Let's see if that works. Of course, I need to log in. Okay, so this is now basically our sample page where we now have the pet status as well. I can request 999. I can request 123. And you can see we get the right responses with the randomly generated URLs and the randomly generated text. But I can also create something new. So if you remember, I only was checking for the name. So if I just create Fluffy, I need to reset the scenarios because we had moved through them. Let's try to create. Now I get a new Fluffy with the status of available. Of course, I can again reset it and say for 1000, I want to change the status to sold. So this also works. If I now do a get for that one, it has the status sold. We can also delete it. And once we have deleted it, the get should also return an error that the pet has not been found. So what I mainly want to show you with that one is that once we have the mock in place, the code of the client doesn't change. It's basically the same as if you would talk directly to the pet store, which is the whole point, right? So we have a mock. We don't need the real backend anymore, but the coding, the whole experience is basically the same, only it's a lot faster and it's perfectly stable. Let me see, what did I want to show you? Of course, automated testing. So I not only want to show you how you can use it during development, but also during test automation. And maybe I can take it from here. So what I want to do is basically take a test code unit, just the basics, and add some test code. For example, we have the random get here. So in line 70, I'm just getting a random number, accessing it in line 18, and then I make sure that I get a successful response, and I also get the right ID that I requested. So this is the randomization, and this is the assertions in the end. If I now go ahead and publish that one, I'm in the test runner, and I can run my random get test. And that one takes only 87 milliseconds, and it has validated the things that we expected. Then we also, of course, need to test our CRUD application or our CRUD scenario. So let's take a look at how that would work. And again, this is not particularly special or specific AL code. Just to show you again, you would do the exact same thing. For WireMock, it makes sense to first reset the scenarios so that you don't see the error that you've seen for me before. But in your automated test, you always basically start on a clean slate. Then we first try to get ID 1000. It's of course not there yet, so it should be false. Then we create it with a new name of Fluffy and make sure that we have created exactly that one. We want to retrieve it afterwards because now that we have created it, it should get the right response. Again, we expect a successful state, the name, the status, and the ID should be right. Then we can modify it by first changing the status to sold and then doing the modify call. Again, we expect a successful return and make sure that the status has changed. We want to delete it. Again, a very similar call, a very simple call that can only check for success. And if we afterwards check it again, we should see that it doesn't return a successful response. So let's try to run that one as well. And if I run that test, you can also see 80 milliseconds. So again, a very fast test. This is exactly how we want it. We no longer rely on the pet store, but instead we have our mock in place and have very reliable and fast responses. Again, the code in Business Central is exactly the same as it would be if you talk to a different system, which is, again, kind of the point of all of this. So with that, you have seen how the test automation part works, but only the basics of it. So we basically now use the mock pet store from Business Central. You have seen how we implemented those actions on the test page. Again, exactly as if we would have talked to the real system, and how we have implemented the automated testing for those CRUD actions. How would you deploy this now? So if you think about trying this at home, how would you run this? During development, it's easy. You can just run VireMock natively on your laptop, on your VM or whatever, or in a container. And the code would be my recommendation to store it alongside your application so that whenever your client changes or the mock backend changes, you have those things in sync and the versioning is consistent. During automated testing, if you use Cosmo Alpaca, this is very easy. There is a concept of a companion container. So you have your development container and a companion container, and that companion can just be VireMock. So to just briefly show you, you would define the companion here and say, this is the image that I want to use, this is the URL that I want to use, and then whenever you create a new development environment, you automatically would also get a new VireMock environment that you can use. Also, VireMock has a paid offering that you can use for that, or if you prefer to use whatever container backend you might have, for example, an Azure Container Instance, a Kubernetes service, that also would be easy. This one-liner spread across multiple lines would be the one to create an Azure Container Instance container. So this is really something that you can easily put into your pipelines if needed. A few closing remarks. Simon talked about the Open API specification, and of course, that was something that would totally make sense to just use the Open API specification, throw it at VireMock, and get a fully generated mock. I looked at it for VireMock, and there it's included in the paid offering, so I didn't want to show this today, but not in the free offering. Basically, yesterday afternoon, I realized that VireMock.net actually can do this in the free version, so that's certainly something I will investigate and probably share on my blog as well. Something I didn't show you for the sake of time, and as we only have 5 minutes left, it was good that I didn't try, is that you can also induce faults and delays. So you can also say something like, on a randomization scale, every third request should return an error, or I want this particular request to take something between 1 second and 10 seconds, so you have a more realistic response time if you do something like load testing or something like that. And then, of course, this is not the only way how to mock. Probably you're aware that there's a new feature in AL, and I think there's even a session that covers it, that you can use to mock your backends. And I would say that is extremely helpful and makes a ton of sense if you're mostly working in AL. If you also have other front ends, if you have also other systems that you want to mock, where you're not only living in AL, then I think VireMock is something that's absolutely worth looking at and can solve a lot of your headaches that you might have around third-party integrations. That's it. With that, we would be very open for questions. Thanks a lot. Questions? I guess the light indicates a question.
I want to ask about Kyoto. Does it also, when it generates the client, does it also handle the negative responses? Like, I don't know, 500, whatever.
You just generate the client to talk with the API. The API will. You mean like handling
I mean the
errors
client
or
itself.
anything?
The client itself, when it gets like 500, does it throw error or just ignores, or should you handle it by yourself?
Right now, the error handling is not very extensive. I only check if it's a success status code and return the response if it was successful. If not, right now we need to add some additional handling for that. So it won't throw an error, so it won't be a runtime error, but you won't get a response if there's an error right now.
That's why you had those get successful state, or what is called. So after the call, you need to make sure that it actually was successful.
Right.
Okay. And does it also work if I would have body as XML, or it's not supported? I mean, in the API
you mean
specification.
XML instead of JSON?
Yeah.
As long as it's in OpenAPI specification, yeah, it would also work. So because OpenAPI also supports XML.
And does this AL part support? I mean, this right now, the one you showed.
Right now, it only supports you mean the access in the model code units, right? It supports only JSON right now.
Okay.
So because it's the more common selection.
The OpenAI specification can be in XML or JSON. So if you have an OpenAPI specification in XML, that would work. But if the actual payload is XML, that won't work.
No, actually, OpenAPI supports payload in XML.
Yeah, but not in the AL
not yet in the AL client, right? Yeah.
Great, thank you.
You're welcome. Oh. That means
Other questions?
one shirt for you.
Anyone interested in topics or in
More shirts?
shirts? Maybe over there.
Yeah, sorry, didn't catch it because, well, first timer here. My question here is how easy is it to share the wiremark? Like, for instance, if we have like the wiremark for the Business Central and we have a third-party client that's trying to integrate itself into the Business Central, how easy it would be to share some sort of wiremark with them if, well, I guess they do know how to use it.
Yeah, I think you basically have two options. The first would be that you share the code, so either the JSON files or the C# code in my example, and give it to them and show them how they can set it up for themselves. Second option would be that you generate a container image using your wiremark, and then they could just spin up a container with that image, and it would have wiremark as you have defined it. And the third option would be that you just spin up a server on your side and let them know here's how you can reach the server. So depending on what level of access you might want to give them, I think those would be the three options.
I see,
Huh?
thank you.
Same problem that I had. Any other questions over there? That's too far.
Thanks. Can you mock also the authentication issues with?
Yes, there is an integration for OAuth 2, if I remember correctly.
Okay.
I stayed away for the demo, and also because in implementations I could so far always exclude it. But yes, I think it can mock OAuth 2, if I remember
Okay.
correctly.
Thank you.
Basic authentication would just be a header and you react on the right one. That's trivial, but we don't do basic anymore, right? Yeah, further questions?
On the left?
On the left? On the left. On the left?
There.
Here.
Thank you. Is there a way to use the Kyoto client if I don't have an open API specification? So I was handling a lot of APIs that don't have a Swagger Lite site where I could have the comfort of seeing all the functions.
I think I saw some tooling that can help you generate the OpenAPI specification, but you can, Kyoto only accepts this. It can be in YAML or JSON, so it doesn't need to be JSON, but it needs to be in the OpenAPI.
Okay, so I would first generate the specification myself if it's not provided by the provider, and then
I think for some default patterns, there are like converters, but I didn't test them myself.
okay, thank you.
Oh, sorry.
Other questions? And I think we don't have shirts anymore?
No more shirts.
So only if you're really interested in the question, but no shirts? Wow, that was too far. Thanks a lot.
Hi. You have shown a clean flow of create and retrieve and delete a pet, but in a real case, does the automation support mocking those relationships as well, or would that still require manual setup in wiremock or test code unit?
How do you mean relations?
You have the pet. In that case, was dog. How do you can you relation a pet with a new customer, or when you make a call with a get? Can you?
Yeah, I think I got it now. So that again would be a scenario where basically you create the customer, you create the pet, and then you assign the pet to the customer. That would just be an API call, and Wiremock would have to know about that, and then the state would move into something like pet connected to customer, and then you could ask which pets are assigned to the customer, and it would return that one. So it's not. Wiremock, in a sense, doesn't have any idea of entities or something like this. It's just URLs and how it reacts. So I think you should be able to model something like this. Yeah.
Oh, okay.
Okay.
Nice. Yeah. Thank you.
Further questions? Doesn't look like it, and we're also at the end, and the only thing between you and the lunch break is us. So thanks a lot. Thanks for
you
coming.
being here.
Please give us feedback. Thanks.
Thanks.